Batteries die so quick on this. Okay. So on those bottom problems, 4, 5, 6, and 7, let me go ahead and dual page it with that example that we did at the end of yesterday, because they ask for the answers a little differently than I showed you. So I think they do ask for vertex, right? Then they do ask for something to the effect of max or min, right? Then they say a max or min value of at. That's where it gets weird, right? Now, before the word max or min, it does say function. So help me out. We've actually seen this year, just you guys forgot. Function value. Back when we were talking about the pre-calc graphing calculator handbook and worksheet number 2, some of the problems had the wording function value. What kind of value were they looking for? The y value. So this is going to be the y at, wait, what were we using to describe where a function was increasing or decreasing at? X intervals. The function value of is the y, at is the where, which is the x. So the nice thing is for this example right here, all they were asking, or all they are asking on 4, 5, 6, and 7, is to look at the vertex and say, okay, what is the, oh, it's a minimum. Why was this one a minimum again? Because the A is positive, which it helps if you visualize. It really does. A is positive. What does that mean? The parabola is, right? A positive person smiles. And a parabola that's concave up is going to have what type of vertex? A minimum. Do you guys get what I mean by min? It's the lowest point, right? Okay, if it's concave down, it's going to have a highest point. Concave up, it's going to have a lowest point. So because the A is positive, concave up has a min. Min value of, what's the lowest this thing goes? 21/4. And when does it go 21/4? It goes 21/4 when x is 3/2. Does that make sense? So make a little note to yourselves on 4 and 5 and 6 and 7. Maybe just on 4 should be enough. When it says of, what follows should be the y value. I put just a little y below. Of would be a y value. And specifically, isn't it the k? Does that help you guys? You can put k. It's the k of the vertex. And which x is going to be this one? The h of the vertex. Good. Does that make sense? Good. Good. Yeah, that was a little tricky, the of and the at. I totally forgot to talk about it yesterday, so I apologize for that. Someone asked me, I don't remember when, but I was like, oh, totally forgot. All right, that helps you hopefully with the worksheet besides that nasty one, number 11. Look, I have them ready for Monday, but I might give you a hint or so today, but we have to grade homework first. So right now, homework spirals open, colored pens at the ready. This worksheet isn't due until Monday. Some of you are already well into it, maybe even almost done. I will give you a hint on number 11, but only after we grade. So here we go, section 2.1. I think I have my book open and ready. Do I? Do I? Yes, I do. Perfect. All right, here we go. 2.1, number 4 should be axis. Was that the axis of symmetry? Is that what they were talking about? I need to put this marker down, or I'm going to write on my smartboard. It's going to be bad news. Okay. Number 4, axis of symmetry. Number 6, negative. If A is negative, concave down, point will the vertex be? Number 10, remember when they're doing matching? Remember when they're doing matching, they describe it a little bit. So number 10 matches with A. But did you figure out it's because, hey, it's concave up with a positive A, and the vertex is -1, -2. That matched the graph. Now pause, look at your homework real quick. Are you guys sketching the parts to the problem that you're supposed to be? If not, I have to take off points. Okay. Bless you, bless you, bless you. Quite a few of you guys have been putting comments in your Google Classroom as far as either attaching work that's late or trying to update me, or some of you every now and then take like a repeated picture of a page and you miss a page, and I'm like, get the right pictures in there. So if you guys have been working on that, I'm going to go through my Google Classroom this weekend and update those grades and then put them into RenWeb. But if I miss something, my grades aren't technically due until Tuesday night, Wednesday morning, unless they changed it to Tuesday morning. But you guys should be able to look over the weekend by like Sunday night and just make sure everything looks right. Google Classroom, there are a lot of assignments. I didn't realize until When? Yesterday? No, I realized this weekend that my notifications were turned off. So all the stuff that you guys might have been posting comments, I was never getting emails. So it's kind of hard if there are all these things that have been done, and I'm like, I'll go back and look at all the assignments, but I don't always see what's new. So those of you guys that have been doing stuff the last couple of days, I've been seeing it, and so I'll go in and I'll correct it. But just keep an eye on your RunWeb. Sunday night-ish, make sure all the homework scores look correct. Is that good? Okay. I think that was, wait, I'm just stopping. Oh, no, there's more. Lo Santo, number 24. I figured that was short. Number 24. Did you guys complete the square? How many of you guys did the h equals negative b over 2a? Oh, okay. I thought maybe one or two would. Is anybody checking with that? Or, okay, a couple, every now and then. Okay. But this one, was this a hard complete the square to do? Didn't have to pull anything out. Taking half of 16 is 8. 8 squared is 64. Put it on the inside, put it on the outside. We would have put it in a different order, but either way. Inside, outside, factor it. Square root the 64 or half the 16. It's a positive because of the positive. Our vertex is, are you guys getting it? Negative 8. You're not making that mistake still, are you? Negative 8, negative 81. Watch out for those signs. Axis of symmetry, negative 8. You can set either the original equal to 0 and factor, or did anybody set the complete the square equal to 0 and try to do it that way? Yeah. You could have gone back to the very beginning. It factored super nicely. Negative 17 and 1 can occur really quickly. But you could have also set this guy equal to 0 to find the x-intercepts. You would have ended up with, just to make sure we're doing it right, it's what the quadratic formula is built upon, remember? And when you square root a squared, what do we have to remember? Absolute value. So therefore, when we take away the absolute value, what's over? Got it. Just like x equals negative b plus or minus square root, right? Quadratic is built on this. So x would equal 8 plus 9 or, sorry, negative 8 plus 9 or negative 8 minus 9. So you would have also gotten positive 1 and negative 17 that way. You could either set him equal to 0, which sometimes, let's just say, if this didn't factor nicely, setting this equal to 0 is doing your quadratic formula. It'll get you the nasty answers too. This won't get you the nasty answers. You'll have to do x equals negative b plus or minus square root. But we only do that when they're asking us what question. Right? And what's the other word they can use that they did in the worksheet? Zeros. So if they ask for x-intercepts or zeros, that's when we're setting equal to 0 and factoring or quadratic formulaing. Anyway, however you would say that. Then you guys see the picture, right? Graph the vertex, graph the zeros. Swoop, there it is. Okay, number 54. Number 54. Did you guys figure out how to do it? Plug in H, plug in K. Oh no, I'm missing A, but I have an X and Y. Plug in the X, plug in the Y, solve for A. 19 over 81. Plug it in and you're done. They gave you all the clues you needed. Plug in H, plug in K. Oh no, who's A? Oh, X, Y. Plug those in, solve for A. Dun, 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 dun. Number 58. I think they just factored, but maybe some of you. Oh, I don't know if completing the square would have been easier. I don't know about that. Factoring out of 2. Ugh. Possible, though. And for those people that never learned the quadratic formula, that's how they would solve it if they couldn't find the factors. But let's review real quick, just because I'm paranoid. Maybe none of you need to see this. But just because I'm paranoid, and factoring is a really, 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 really important skill, like the unit circle that people just kind of underestimate, ignore, dislike, so shove it off to the side. Sometimes to rise above our own natural prejudices for the better good, for the common good. What do I mean? If you don't like it, too bad. Press in. What am I saying? Press in, persevere, have some grit, toughen up, be a man, be a woman, I don't know. Take it like a man, take it like a woman. You gotta do what you gotta do. How many phrases can I use? Let's just stop. What goes in my X if I have a number in front? A times C. What goes down here? B. What factors of negative 6 add to B5? Wait a minute, that doesn't work, does it? So if you would think 2 and 3, but I don't think 2 plus 3 won't get me a negative 6. And negative 2 and negative 3 don't quite work either. So what's the better option? How about 6 and negative 1? If you're stuck in the x method, you have to group. So you would keep your 2x squared, you would keep your negative 3, but what does this point to? How he breaks apart. And he breaks apart to be a 6x, and he breaks apart to be a negative x. Then we do our grouping. Put a little plus, it's not times. It's not times. Factor out a 2x. Factor out a negative 1. Do they match? Yes. Can you pull out the x plus 3 and solve? Yes. But for some of you that might be trying to guess and check, the only ways to get 2x squared are 2x and x. The only ways to get 3 are 1 and 3. You could just play around with the order until you get the correct outer 6x with the correct inner negative 1x. Dun, 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 dun. Is anybody trying guess and check? Okay. Keep playing with it. Keep playing with it. It makes it so much faster once you master it. But it's going to take time. It's going to take practice. But if you are using the x method, you've got to do it correctly, or else what's the point? Just learn quadratic formula, I suppose, and do that every time. But that's not a good idea either. All right, factoring is important. Please don't forget. Why was this one messy? And they did it by hand. Did some of you just want to do your calculator and find the max? Maybe some of you did, cheaters. What were you supposed to try to do? It by hand? How could you? Hey, do you have something similar in your worksheet, numbers 8 and 9? Are they kind of messy? A little bit, right? They have nasty fractions, etc., etc., etc. They're a little bit nasty, but they're not impossible if you just take it step by step. When the ball's punted, time is 0, which is why they just plugged in 0 and figured out the initial height was 1.5 feet. Why does that make sense that it wouldn't be 0? How does punting a football work? Kick it? Oh, like it's in one of those little placeholder-y things, like a tabletop on a pizza? Oh. Can the hand go down and touch the ground? No. So it's going to start a little bit off the ground, right? This one, it was 1.5 feet. Maybe the kicker was kind of short. I don't know, 1.5 feet. I feel like mine would be higher, right? Because you kind of like meet it. I don't know. But this guy was only 1.5 feet off the ground. Why? You plug in when time is 0, the beginning of the scenario. What's going on with letter B if you're finding the max? Why are they plugging into this formula? What did they not want to have to do? Complete the? They were like, nope. And I would have probably done that too. Nope. Those are, ugh. I mean, you would have had to, ugh. So they just plugged in a negative b over 2a thinking that it would be a little bit easier. It's still a nasty number when you simplify and solve that fraction. And then, it got even worse. But at the end of the day, it is a decimal. At the end of the day, we would have given you some grace. You wouldn't have had to do all that math by hand, even though you could have with lots of 2-column multiplication and all this weirdness going on. Wouldn't have been impossible, but it would have been messy. So some of you are like, if I'm using my calculator anyway, why don't I graph it and find the max? That's a great way to check the answer. Okay. But how would you do letter C? Letter A, just plug in 0. Letter B, find the max using the vertex, that stuff that we've been talking about. And letter C says how long the punt was. When does the punt stop in this scenario? Did someone catch it? What happened to the ball? It hit the ground. So then what do we set the height equal to? 0. How do you solve? What are they doing? X equals negative b plus or minus square root b squared minus 4ac all over 2a. Why? Because they were like, this one's even too nasty for complete the square. You could have. It just would have been gross. And how could you have checked it? Graph your parabola, find the 0, and then you would have been fine. Okay? So letter A, t is 0. Letter B, find the vertex. Letter C, find the other x-intercept or the other 0. The same questions as you were seeing all homework long. Just you didn't like the numbers, and I get it. I get that you don't like the numbers, but you had to kind of power through. Any questions on evens or odds? Going once? Tony. 50, which one? 58? Anything else besides 58? Kyle? 54. 54? Both evens? Bummer. Thought I answered. Okay. No odds, though. Oh, stink. Every now and then this file is a little bit corrupted. Oh, it showed. Go team. Okay, 54 and 58. 54. Kyle, what you needed to see was that it gave you the vertex, and we can call the vertex H and K, right? They also gave us a point. Some of you might have heard me give this description a little bit earlier. So if I have X, not just any X though, I have H. And if I have K, and if I have an X and a Y, and then if I go to standard form, Y equals A times X minus H quantity squared plus K. Normally we just plug in the H and the K. Normally, but the problem is we're supposed to plug in H and K and A, but do we know A? So then this time, to find A, he's my only variable allowed to stick around. I better go plugging in the Y and the X at the same time. Simplify that puppy for A. You'll end up with your final equation of Y equals whatever that A is. X minus H squared plus K. Does that make sense? Yeah. Oh, what got nasty? I would change the -2 to be -4 over 2, right? I think that makes it a little bit easier on your brain. So if I have -4 over 2 minus 5 halves, that'd be -9 halves. Squared would be 81 fourths. And then since I see fourths everywhere, I would change this guy to 16 fourths, just to make my life a little bit easier.
I just read the square.
Yeah. Yeah. Number 58, Tony, that's the one that you were looking at, right? Okay. Oh, got it. So you weren't sure how to confirm. Got it. Okay, I think that's it. Worksheets, put them in your homework spiral. Homework, go ahead and put away. Well, worksheets. Nope, I said I was going to give you a hint on 11. I am so sorry, and I will. So sorry. I'll give you a hint on number 11. So give me just 1 second with that worksheet as you guys have it out. Because a lot of you guys were working on it. Some of you haven't yet. But for those of you that have been working on it, think through what we did yesterday. Okay? What are some important phrases that you circled or that you thought about as you were going through the problem? What are some important things? 1200. Fencing. What else? What are they asking for? Why am I going to come over here and write perimeter and area again? Where did I get perimeter from that problem? Oh, come on. You don't forget that easily, do you? Enclosure, but not just enclosure. That's the inside part, right? Dimensions make me think of like bases, heights, lengths, widths, area, perimeter, but why perimeter? There's no word. Are you thinking, Angelique? How come? Fencing. What does fencing do? Is it in the inside? No, it's the around, right? Okay, so fencing told me perimeter. And then area, what made me think of that? Fencing has to do with perimeter. Not dimensions, that's just length, width, base, height. What made me think area specifically? Can anybody see it in the problem? What made me think area? Fencing is around. Come on. Someone has it. Why areas? 2 paddocks. You guys know what paddocks are, right? Like horse enclosures where they keep paddocks? Maybe not. Anyway, just think animals inside like a fence. I think it's a horse terminology with paddocks, but anyway. Fencing is around. What made me think of the inside? Inside is area. Enclosure. They want the largest enclosure, aka they want to figure out the, what was that actually saying? Find the maximum area. Translate. Translate the math. What dimensions? Find the length and the width. Find the, I'm guessing X and the Y. We haven't even written the or labeled the picture yet, but it's saying the largest enclosure, the largest inside. They don't care about the fencing. I mean, we only have so much anyway. They care about the maximum area, making the biggest paddocks possible. Now, what are we missing for both of these? We didn't need numbers yesterday at first when we did them, though, right? What were we doing first yesterday? Yeah, perimeter area formulas. So why is this one that much harder? Why isn't it just 2x plus 2y, and why isn't it just x times y? How'd you guys label your picture? How many x's are there? Oh, you need fencing here and here and here. Mm-hmm. Now, y you could label it a couple different ways, but just for sake of simplicity, I think it'd be easier if you labeled the whole fencing on the bottom y, because you could just run one line of fencing, right? I think that'd be the easiest way. So question, what would be your formula for perimeter? 3x plus 2y. That's where it changes. P equals 3x plus 2y. And what's going to be still your formula for area? X times will get you the whole thing. So x times y will get you the whole thing for area. 3x plus 2y will get you perimeter. I'm not going to write any more down, but I will come back to this page for just 1 second and say, hey, yesterday when we got our formulas for 2x plus 2y and xy, I walked through on the video exactly what to do next, okay? So if you're still stuck on number 11, I just gave, at least verbally, I just gave how to make the equations for perimeter and area for number 11. Then you can follow our steps yesterday as to, well, did I finish the problem yesterday? No. But I got all the way down to area being a quadratic, reminding you they're asking for the maximum. And how do you find the maximum area or the maximum of a quadratic? Find the vertex. The maximum is going to be the vertex. And should you know how to find a vertex by the end of this homework, this section, this worksheet? I hope so. So what are you doing for number 11? Finding the maximum of hopefully eventually a quadratic, aka finding the vertex. See what you can do. That worksheet is due on Monday, but for right now, we're going to section 2.2. 2.2. There's a lot on this page, and I know the glare gets kind of hard sometimes. Let me turn off another light just to give you guys kind of a little bit of a break on your eyes as you work in your notes to get down section 2.2, the beginning. Go ahead and submit it tonight and write a little comment reminding me why. Yeah. Do you guys turn in copy to your period 1 classes today? Oh, next week? I got 2 back. What? Go my period 1. They're on a roll. Did anybody tell you about, oh, I shouldn't be helping you. Never mind. Well, no, there's a sale on today at a grocery store that rhymes with ponds. Sure, that works. Where you can get 3 pounds of coffee. 3 pounds, that's worth 3 points for only $5. I won't tell you what brand, though. You have to go figure that out yourself. But there's only, oh, good question. Vons or John's? Only one of them has $5 Fridays where they always have specials for $5. Your parents might know. Yeah, John's doesn't really do that. Well, it has like a bigger variety of food though. I went down to Brazil a few different times and there was this soda that you could get on the flight that's like Brazilian. Is it Guaraná? Is that what it is? Man, I haven't had it in a while. And John's has it. It has a wide variety of foods from different places, which is kind of cool. Vaughn's has some, but anyway, take it or leave it. A teacher in teacher's meeting today made us aware of the sale, which was a nice thing to do. But you could also bring in some good stuff. Starbucks, £1, about $10. That'd be some good stuff. If you're looking for a deal, yeah. $5 for £3 isn't bad at all. What do you guys notice in this title for section 2.2? Polynomials. Okay, good. So not just quadratics, not just linear functions. I guess linear are binomials, kind of. Not all binomials, but all binomials where x is to the first. Quadratics are usually trinomials, but these ones are just all polynomials. Oh, I forgot Jean's Day money today. Bummer. You guys close? Polynomials of higher order degrees. Guess what? Not quadratics anymore. Not in Kansas anymore. We're going to cubics and quartics and beyond and beyond. We're going to cubics and quartics and beyond and beyond. The problem is with cubics and quartics, the math might get a little bit harder. Because some of you guys thought factoring was hard. But the nice thing is, before we get to factoring, synthetic division, long division, the rational root theorem, the factor theorem, etc., etc., etc. Before we get to all of that, we get to talk about some general things to do with these polynomials. Let me turn back on the light. I don't know about you guys, but when it's dark and when it's warm and when it's cozy, man, I get sleepy. Let me open up the door as well. Okay. A couple things about polynomials. First of all, the graphs of polynomials will always be continuous. What does that mean? As you're drawing a polynomial graph, you'll never have to break it. You'll never have to go to a vertical asymptote. You'll never have to jump over a hole. It'll always be nice and smooth. Speaking of smooth, polynomials will only have smooth turns, not sharp turns. You can have breaks and holes in piecewise functions for sure if they don't match up. You can have sharp turns in absolute value functions or piecewise functions, but those aren't polynomials. So polynomials will never have to worry about holes or jumps, vertical asymptotes. We'll never have to worry about sharp turns, always smooth. And at the end of the day, in this section, our goal is to be able to roughly graph polynomials that are cubics and quartics and beyond. You can't really perfectly do it without calculus. But we can do a pretty good job, at least better than last year probably as far as visualizing graphs. And we've already talked about how visualizing graphs is useful. Visualizing graphs for certain regions, we can find maximums and minimums. Oh dear, maximums and minimums. Visualizing graphs, we can do things like domain and range, how far left, how far right, how low, how high. We can, with graphs, talk about things like increasing and decreasing, how a quantity is moving and changing. So let's talk first of all about basic graphs of monomials. What if there's only one term and x is being raised to some power? Only one term, no weird adding, subtracting that's changing it up. In general, for monomials, where x is being raised to different powers, in general, if the power is even and n is greater than 0, if the power is even and n is greater than 0, aka, guys, what does it mean if n is greater than 0? Good, good, good. If n is a positive number. If n was a 0, the whole thing's 0, so forget it. It doesn't really do much. Well, careful. If n was 0. Oh, yeah, it's in the power spot. What's anything to the 0 power? Just 1. Well, that's boring. Y equals 1 is a flat line. That wouldn't be very polynomial-ish. Okay, so if n is greater than 0, n is positive, and an even number. And an even number. It's going to look something like a parabola. Now, I want you guys to grab out your graphing calculators, and I want you to graph x squared, x to the 4th, x to the 6th, and I want you guys to see how they do change. Why do I say that basically looks like a parabola? Get out your graphing calculators. X squared, x to the 4th, x to the 6th. If you want to go crazy, x to the 8th, x to the 22nd. Check it out. Why am I saying they're all going to look basically like a parabola? Wouldn't it change? Wouldn't it be different? The powers, man. If you raise something to the 4th, it's a whole lot different to the squared, or raise something to the 6th, it's a whole lot different than the 4th. The numbers would be way, 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 way higher, wouldn't they? But does the shape change? Peek around your groups really quickly. Make sure everyone has a calculator. If someone doesn't, help them out and show them what you got. X squared, x to the 4th, x to the 6th. If you want to go too crazy, x to the 22nd, x to the 44th, something that's even.
Whoa. I like x to 22nd.
Why am I saying basically it'll look like a quadratic? I'm going to go x to the 42nd. Ooh.
Oh, yeah. A box, yeah.
Whew. Now, those of you guys with colors, I'm a little bit jealous. I'm a little bit jealous because you can see it a lot nicer than we can. But guys, do you see why I'm saying they basically all look like this? Something's changing every single time, but what's changing? They're just getting more and more narrow. Why are they getting more and more narrow? If I raise 2 to the 2nd power, x squared, 2 squared, that's 4, right? Here, let's do that. Let's go to our second trace, the value button, right? Let's go to our value button. I want you guys to plug in x equals 2. Right now, y equals 4, you're on the x squared graph. How do you go to the x to the 4th graph? You go up. What would be 2 to the 4th? Oh, it doesn't go? Party poopers. I thought it would go. Hold on. Second calc value. Can I go in a different graph?
You have to go down. You have to go down.
Oh, is it down?
Yes.
Did that work for yours?
Yeah.
Oh, there you go. That's weird. Okay. To the 4th power, 2 is 16. To the 6th power, 2 is 64. To the, I put in 42nd power, 2 is, uh-oh, it freaked out on me. Oh, no, that's right. 4.398 E12. What does E12 mean, my chemistry people? Times 10 to the 12th, right? Scientific notation. Whew! So what changes? How steep it is based on the powers. X to the 42nd is going to be way higher than x squared. But still, what's the general shape of the graph? For all of them. Now I want you guys to change all of your y equals to odd powers now. Don't do x to the 1, that's just a line, that's boring. But do x cubed, x to the 5th, x to the 7th, x to the 39th, I don't know, be creative. And I want you guys to see how those change. And then I want you to sketch for me the general shape of an odd powered graph. What would be the general shape of an odd powered graph? Mm-hmm. Oh, I guess that makes sense. I didn't think about that. How it could just be thinking about the original. I'm going to go to the 31st. Why not? Boop, boop. When Baskin Robbins has scoops for a whole lot cheaper. How much are Baskin Robbins scoops on the 31st? It's cheaper. Like $1.31 or something? I don't know. I forget. Okay. You guys see what's going on? What's the general shape? You could think half of a parabola that's up and half a parabola that's down. Why does that make sense? Kind of. What happens with negative numbers when you raise them to an odd power? They become negative. What happens to negative numbers to an even power? They become positive. So the y's will be positive for even powers. The y's will be negative for odd powers. You guys going to start doing the math dance? Okay, anyway, so odd powers are going to basically look like x cubed. Now here's what I want you guys to do. Colors might be a little bit helpful today. But long story short, I want you guys to circle where the arrows are. Because for right now, for a monomial, this is good enough. For a monomial, one term, whether there's a 4 times x squared, whether there's a negative, that's going to maybe have a reflection. But whatever constant is in front, if I was to change this just a little bit, and if I was to say something like, okay, what if we put an a now? The shapes won't really change. I mean, you'll have a vertical stretch or a vertical shrink, but the shapes will remain the same unless a becomes negative. And if a becomes negative, what's going to happen? Yeah. So these are for a being positive also. If a is negative, well, then you're going to have a reflection instead. So if a is less than 0, you're going to have a downwards. Ooh, that's a wide parabola. Not that that's bad necessarily, but if a is negative, you're going to have those facing down. If a is negative, you're going to have this vertical reflection going the opposite direction, right? What? They're the exact same? No, they're not. No, they're not. One's concave down parabola, concave up parabola. One's a positive cubic, negative cubic. But anyway. Oh, I didn't put my negative a or my a less than 0. So if you don't have different colors, maybe don't put the negative a's, or maybe draw them separately, because if you don't have the different colors, you're going to get a little confused as to what the graphs are actually supposed to look like. But if you do have different colors, you can color code it. Just make it clear on yourselves, otherwise it's going to get a little bit nasty. But those are basic graphs, monomials. But if I go doing other stuff, like, remember, wasn't it the beginning of 2.1 where we wrote that really long general polynomial? Can't any nth degree polynomial have n plus 1 terms? So what happens when you start adding and subtracting lower degree terms? If you have an x to the 42nd, you could have 43 terms with x to the 41st, x to the 40th, x to the 39th, x to the... Oh, I could go on forever. All of a sudden, even though some things stay the same, some things will change. Let me go ahead and circle really quickly these parts, because guess what? No matter what you add or subtract to an nth degree polynomial, no matter what you add or subtract, or how many terms you add or subtract, one thing, or I should say 2 things, will remain the same. Maybe not how the middle looks, but the ends, E-N-D, the ends will look the same. As long as a is positive, the leading coefficient of the nth degree term or the highest degree term, the ends will still be pointed up. Maybe weird stuff is going on with curves and weird turns, but the ends will remain the same no matter what you add or subtract. Oh, I already did this page. Well, let me change this just a little bit, because I didn't show you the snazzy notation for the end behavior test. So let me go ahead and do this instead. Let's say, there we go. I'm going to put a plus ... What does that mean? Does this have to be a monomial anymore, guys? No, doesn't have to be a monomial anymore. But a is still the leading coefficient of the highest degree term. And he's the guy that we base all this on. I am going to actually give you guys notation, the snazzy notation that's actually kind of getting you towards calculus. Let me just delete all of these other ones and get the baby graphs. Let me give you the notation of how you would need to answer these types of questions in homework for the N behavior or leading coefficient test. Okay? If N is even is if N is odd. Okay. If A is greater than 0, we just talked about N is even, concave up like a cup, it looks like a parabola. And we just talked about how no matter what else there is, somehow it's eventually going to be going up to the right and up to the left. I don't know exactly what's going on in the middle once you start adding and subtracting stuff, but I do know it's going up to the left and up to the right. And if A is negative, I know somehow eventually it's going down to the left and down to the right. But how do you show that mathematically? Mathematically, we can make the following two statements for this one. We can say, as x goes to negative infinity, f of x approaches. And then we can also say, as x goes to positive infinity, f of x approaches. Now, I'm actually going to write this for each of the different categories. We're going to fill it in just a second as to what the different answers are, because we haven't filled in what f of x is approaching. But I want to talk through the notation. But let me have you guys, first of all, write it for all four, because the answers are going to change just a little bit depending on the situation that we have. But every time, as x goes to positive, sorry, I did negative infinity first. And then as x approaches positive infinity. I'm just going to write that for every single one. For the odd ones as well. And maybe by the end of writing this 4 different times and writing a new notation 8 different times, maybe you'll know what the arrow means. Maybe you'll know what the arrow means. As x approaches negative infinity, f of x is going to be approaching. As x approaches positive infinity, f of x is going to be approaching. What's the new notation? What's the arrow mean? I've said the word at least 5 to 10 times in the last 2 minutes. What word was I using for the arrow? Good. Good. Adam, say it louder. What was I using for the arrow? The arrow is going to come back and be a really important guy in chapter 12. A really important guy in chapter 12. Last chapter of the textbook. The arrow is approaching. And here's where we're going to end. We're ending at end behavior. You're welcome. Here's where we're going to end today. Even. What did I say it looked like? You guys graphed all these even-y guys. What were they doing? Who knows what's going on in between? But this is what's going on in the ends, right? So if it's increasing, if the function is increasing to the left and increasing to the right, guess where the y's are going? Where are they headed? They're up, 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 and away. Positive infinity. But what's going down if a for an even is negative? Down to the right, down to the left. Where are the y's going? To the right or the left? Negative infinity. But an odd function, what does he look like? If a is positive, as x goes to negative infinity, which means to the left, what are the y's doing? They're going down. But to the right, they're going up. And what switches if a is negative? To the right, we're going down. And to the left, we're going up. All right, cool kids, you can start this homework. Not sure if you can finish, but you better finish that worksheet by Monday. Worksheet, no Google Classroom pictures. Bring it ready to turn in Monday after we grade it all together. Bye, guys. Worksheet for Monday. This homework not until Tuesday. Maybe you can start, though. That'd be cool. Happy weekend, almost. Hang in there for the rest of your Friday.